Hello everyone. In this video, we are going to do a simulation in the Proteus using a gas sensor. For a gas sensor MQ4, MQ4 is a gas sensor that is specifically designed to detect natural gas like methane and other components. So in this video, we are going to expose that the sensor will detect the natural gas. But in Proteus, you can our model is to behave. It's a behavior of like detecting the gas. We will do a simulation like if a gas comes into the gas sensor, then what will happen to the gas sensor. So let's move on to the simulation. Here is the simulation for the gas sensor, and this gas sensor works on the principle of resistive charges. Like the sensitive layer will be exposed. If gases came into the sensor, then the sensitive layer will resist that the gas will came into this gas sensor. So after this, the MQ sensor is sensitive to methane, but also can detect other gases also like propane and butane, like many gases it can sense. So this sensor we are using to connecting to the Arduino Uno board, and this to simulate gas concentration changes. You can adjust the voltage also to the analog pin connected to the MQ4, and programming will coming to the programming part. So this is the code I have written for this gas sensor to detect the gas. In this code, we will explain line by line. We will break the code line by line. So in this, I am using liquidcrystal.h. I am including this library file, and the MQ series of the gas sensor are used to detect various gases. I already told. I am using an LCD display, the liquid crystal display, that is used to provide a visual output showing message such as gas detected. I am showing a message. It is a gas detector. In this LCD, I am showing a message like I am using a gas detector. Here I am showing this message detector gas. I am printing to the LCD. I am printing to the LCD that it is a gas detector. If the gas is detected, then I am printing gas detected. So these two messages I am printing to the LCD liquid crystal display, and next line I am using liquid crystal LCD 7654321. This means the LCD I am using, I am controlling the LCD to these pins only. I am initializing the specific pins 765432. These pins to I am connecting to the LCD, so that I can print this gas detector and gas detected message. So next I am next to define MQ pin A0 and define buzzer 1. This means MQ pin is defined to use analog pin A0 for the MQ gas sensor. I am using this A0 pin, analog 0 pin, to the MQ gas sensor output. I am getting the output from the gas sensor pin, output pin, and connecting to the analog pin of the A0 MQ pin, analog 0. Then I am defining buzzer 1. Buzzer 1 is defined as pin 1 for buzzer. Pin 1 is defining, I am defining the pin 1 for buzzer. So next, as usual, we are setting up void setup function and on void loop function. In void setup function, I am initializing all the variables and pins I want to use in this simulation. So in this, the setup function is used to initialize the LCD. I am using a 16:2 configuration of LCD. So LCD begin 16:2. 16:2 means I am using the 16:2 pin LCD. So next, the MQ pin is set to input as a internal pull-up resistor. I am using the internal pull-up resistor as an input, so that this MQ pin is setting to input pull-up. I am using the keyword input pull-up. The buzzer is set to output. The buzzer is always set to the output because buzzer is an output device. So that using buzzer we can indicate that output is detected. So I am setting the buzzer as an output device, and the LCD displays gas and detector for 1 second before clearing the screen. That is 3 1. I am giving set cursor. That is the LCD will third row and first column it will print. So LCD print with gas detector for 1 second before clearing the scene. Then we are coming into the loop function. In the loop function, what we are doing is the loop function always continuously check the gas value from the MQ sensor. Now we are the value from gas sensor will come into this loop, and then the loop will continuously check the gas sensor value. It will not stop until we are stopping the simulation. So in this gas sensor I am using if gas value is high, then it's indicate that the gas is detected. The buzzer is activated this using this function. Buzzer is activated. High means the buzzer is activated now. The LCD will display gas detected in this set cursor position. We are setting. We can give any position we want. I am giving the gas should be printed in this position and the detected should be printed in this position. The display is cleared after a short delay. The display will be cleared after a short delay. I am giving a delay here. The display will be cleared after this delay, and then the buzzer will be turned off. I am turning off this buzzer if the gas is not detected. If the gas is not detected, then the buzzer will be in off low. Then the LCD will not print any message. It will be print this message only, gas detector. So the same this is happening in this code. So incorrect readings, if the MQ sensor is not configured correctly, it may provide accurate readings. So now we are going to compile this program. Check that is Arduino Uno we are using, not Arduino Uno Mini. Arduino, change it to Arduino Uno. Arduino Uno, then get it compile. Now compiling. After compiling, we want to extract the hexadecimal file from this compilation stage, and then we want to dump it into the Arduino board we are using in Proteus simulation, so that the whole code will be dumped into that Arduino board. We are using a MQ4 gas sensor. So that gas sensor we want to go get it into the library, and we want to get the hex file of the library file from of the gas sensor MQ4, and we want to dump it into the gas sensor also. So now done compiling came. So extract the hexadecimal file. Here you can find the hexadecimal file. Till here you can copy, and I am going to the simulation I have shown before. Now this is our simulation. The Arduino board is get connected to LCD display, 16 to LCD display, and the gas sensor out is connected to the A0 analog pin. As I told here, I am giving this A0 MQ pin A0. MQ pin A0 means here the out of the MQ pin means the MQ gas sensor. Out of the MQ gas sensor is connected to the analog A0 pin, and the LCD configuration we have mentioned as a 654 that we have mentioned, also connected to the LCD display. After that I am connecting a buzzer. To indicate that gas is detected or not. I will show the display the gas detector message here only, and now we will come into the program simulation part. To simulate gas detection, this can so we want to do this gas sensor also. Gas sensor we want to update. So here program file we want to click, and gas sensor, it is in gas sensor only. So okay, now I am going to run the simulation part. Now it's getting gas detector message, not detected message, it's coming as detector message. So now gases are getting detected. So after, if we want to, we are just doing a simulation part, so we don't need to give a real gas into this simulation. So I have connected a logic state here. A logic state is connected to the test pin. This is test pin. If the gas is detected means we can change the value to 1. Then the value is 1 means that is like open. Then the gas is test pin. It's like a test pin, just a test pin. It will detect 0 means no gas, and 1 means gas will be detected. So if I change this to 1 means the test pin will tell the Arduino board that the gas is detected. So the LCD will display gas detected message. So I am giving 1 here. Gas detected message came. Now the test pin is telling to the Arduino board that gas is getting gas is came into the gas sensor. So it is initializing a message that is gas detected. So this is the simple program for the simple simulation for the gas sensor MQ4. Thank you.